Since first arriving at the Kennedy Space Center 25 years ago, Space Shuttle Atlantis has made the 4-mile trek from KSC's Vehicle Assembly Building to its oceanside launch pads more than 30 times. The fourth of NASA's 5 orbiters, Atlantis' career has not been lacking in firsts. Among them, the first shuttle to deploy a probe to another planet, the first shuttle to dock to a space station, and the first shuttle to fly with a glass cockpit. And now, Atlantis will lead the shuttle fleet to a first, as it becomes the first space shuttle to complete its scheduled flights. Atlantis will return to Earth to stay following its mission on STS-132. The array of missions Atlantis has flown is as wide as the oceans once sailed by the 20th century research vessel for which it was named. Atlantis has flown missions for national security, for interplanetary exploration, and to foster international cooperation. On October 3, 1985, Atlantis launched from Pad 39A on its maiden voyage, STS-51J.
Ignition and liftoff. Liftoff of Atlantis. A new orbiter joins the shuttle fleet, and it has cleared the tower.
Commanded by shuttle veteran Carol Bobko, the classified Department of Defense flight was the first of 5 Pentagon missions Atlantis completed. After traveling more than 1 million miles, Atlantis landed at Edwards Air Force Base just 4 days later, on October 7th. Later that year, on just its second flight, Atlantis set a shuttle record for the least amount of time between missions. On November 26th, the orbiter headed back to space on STS-61B, just 50 days after completing its previous flight. Making his first space flight on that crew was mission specialist and spacewalker Jerry Ross, whose 7 career space flights, including 5 on board Atlantis, would set a record matched by just 1 other astronaut. 3 communication satellites were deployed during the flight. During 2 spacewalks, Ross and Woody Spring also conducted a construction experiment to demonstrate the feasibility of assembling large structures in space. The successful experiment was an early proving ground for the engineering and construction of future space stations. During the next 3 years, Atlantis flew just 1 mission. The tragic loss of Space Shuttle Challenger and its crew in January 1986 prompted the grounding of Atlantis and the rest of the shuttle fleet until September 1988. In 1989, Atlantis was back in action, completing 2 missions to provide a closer look at 2 neighboring planets. The primary payload for STS-30 in May of that year was the Magellan spacecraft, designed to capture radar images of Venus. Magellan, which was the first interplanetary spacecraft launched from a space shuttle, eased into orbit around Venus in August 1990. Mapping 98% of the planet before its mission came to an end in October 1994. 5 months later, on STS-34, Atlantis was back in space for the deployment of the Galileo spacecraft on its voyage to Jupiter. It took 6 years for Galileo to arrive at the solar system's largest planet, and when it did, it became the first spacecraft to both orbit and release a probe to penetrate through the atmosphere of an outer planet. It collected data on Jupiter and its moons for the next 8 years.
And flight crew, this is OTC. Close and lock your visors. Initiate O2 flow. Godspeed on the 100th U.S. manned mission in space. Flight crew copies, visors in O2. Thanks for the great help.
On June 27, 1995, Atlantis embarked on a mission which significantly expanded the new era of international cooperation.
2, 1, and liftoff of the Space Shuttle Atlantis on a mission that will herald a new day of international cooperation in space.
Houston now controlling.
STS-71 was the third mission of the Shuttle Mir program. But Atlantis, whose crew included cosmonauts Anatoly Soloviev and Nikolai Budarin, became the first shuttle to dock with the Russian space station Mir.
After 20 years, our spacecraft are docked in orbit again. Our new era of space exploration has begun.
The crews conducted a host of biomedical investigations and transferred equipment. The mission also marked the first on-orbit exchange of shuttle crew members. Astronaut Norm Thagard and cosmonauts Vladimir Dezhurov and Gennady Strikalov, who flew to Mir on a Russian Soyuz vehicle, returned to Earth on board Atlantis. In a complex orbital ballet, Soloviev and Budarin captured these images from their Russian Soyuz, which undocked just minutes before Atlantis departed Mir. The union of Atlantis and Mir created the largest spacecraft to orbit the Earth at that time.
And it's just about time for the Spirit of 76 to wake up the space coast, so have a great plane. All right, we'll put that in work. Thank you very much.
2, 1. Booster ignition and liftoff of Atlantis on the third Shuttle Mir docking flight.
Atlantis visited Mir on its next 6 flights. The crew of the STS-76 mission in March of 1996 included Shannon Lucid, who became the first American woman to live on Mir. Her 188-day stay on board the station set an American long-duration spaceflight record at the time, a record for most days in space by a woman, and initiated a continuous U.S. presence on Mir for the next 2 years. And astronauts Linda Godwin and Rich Clifford completed the first U.S. spacewalk around 2 docked vehicles while wearing jet backpacks known as Simplified Aid for EVA Rescue, or SAFERs. In the spacewalk, they attached 4 environmental payloads to the Mir's docking module. Atlantis flew to Mir 3 times in 1997, but the last of those flights, STS-86, was in question up until its scheduled launch in September. Safety concerns arose after a Progress resupply ship collided with Mir a few months earlier during an attempted manual docking. The collision damaged the Mir's Spectre module, which had to be sealed off from the rest of the station because it was losing pressure. On the day Atlantis was scheduled to launch, NASA Administrator Dan Golden summarized his decision to proceed with the flight.
Not only is the Mir station deemed to be a satisfactory life support platform at this time, but it is anticipated that significant operational and scientific experience is still to be gained through continued joint operations.
Atlantis docked to Mir on September 27th. Over the next 6 days, the crews transferred consumables, experiments, and other materials. Scott Parazynski and Vladimir Titov also conducted the first joint U.S.-Russian spacewalk, installing an external device to help seal the breach in Spectre from the vacuum of space. The continuous U.S. presence on Mir was preserved as astronaut Dave Wolf joined the Mir crew, replacing Mike Foale, who returned to Earth on board Atlantis. In 2000, almost 2 years after Zarya, the first component of the International Space Station was launched from Kazakhstan, Atlantis completed a pair of missions that were crucial to the development of the ISS. During STS-101 in May of 2000, Atlantis' astronauts outfitted Zarya for the July arrival of the Zvezda service module, essential for sustaining the first long-duration expedition crew. And on the mission, Atlantis became the first shuttle to employ the new Advanced Instrumentation Display System, known as the Glass Cockpit. On STS-106 in September 2000, Atlantis delivered supplies and Zvezda was opened for business for the first time in preparation for Expedition 1, the station's first crew. Their arrival in November marked the start of a continuous human presence on board the ISS that remains unbroken.
liftoff of Space Shuttle Atlantis with Destiny.
Atlantis returned to the station in February 2001 on STS-98 to deliver Destiny, the 28-foot-long U.S. science laboratory and centerpiece of the U.S. segment of the outpost. Destiny greatly increased the pressurized volume of the station and would be the home for scientific investigations, living and environmental control of the U.S. segment, and robotics control for the Canadarm2 robotic arm. Bob Kerbeam and Tom Jones conducted 3 spacewalks to help install Destiny and to relocate pressurized mating adapter number 2 from Unity to a temporary location on Destiny. In July 2001, Atlantis was part of another station milestone. The primary objective on STS-104 was to install the Quest airlock, the emblematic front door of the station. The airlock would become the main path to exit and re-enter the station for U.S. spacewalks. Mike Gernhardt and Jim Riley completed 3 spacewalks to help install and outfit Quest. The third EVA, the first ever using Quest, occurred on the 32nd anniversary of humanity's first landing on the moon. The first mission for Atlantis in 2002 was STS-110 in April, the 5th International Space Station assembly flight for Atlantis. The crew once again included Jerry Ross, making the last of his 7 space flights. Using the shuttle and the station robotic arms, the combined crews installed the S0 truss segment, the central piece of the station's integrated truss structure, the backbone of the ISS. Also delivered was the mobile transporter, a railcar-like device designed to move back and forth along the truss system.
Coming out of their crew quarters as a unit on the 3rd floor.
In 2003, the loss of the Space Shuttle Columbia and its crew prompted the grounding of the shuttle fleet for the 2nd time in history.
And our astronauts coming in.
Following 2 return-to-flight missions by Space Shuttle Discovery, designed to test safety procedures, Atlantis stood ready to support STS-115 in 2006.
It's been almost 4 years, 2 return-to-flight missions, and a tremendous amount of work by thousands of individuals to get the shuttle program back to where we are right now. And that's on the verge of restarting the station assembly sequence. We're ready to get to work.
After several weather-related delays, Atlantis finally headed skyward for the STS-115 mission on September 9, 2006. The crew conducted 3 spacewalks to install P3, P4, critical truss segments on the port side of the station, and a pair of solar arrays. The mission also marked a milestone for the Canadian Space Agency, as astronaut Steve McLean became the first Canadian astronaut to operate both the station's robotic arm and the mobile base system in space. STS-117 in June of 2007 closely mirrored STS-115, with Atlantis and its crew delivering S3, S4, the next truss segment for the starboard side of the station and its solar arrays. The mission also included a space station crew rotation. Astronaut Clay Anderson became a member of the station's Expedition 15 crew, replacing Sonny Williams, whose 195-day stay on the station set a new long-duration spaceflight record for women, eclipsing the record set by Shannon Lucid on board Mir. The sole flight for Atlantis in 2008 was STS-122 in February. The highlight of that 13-day mission was the installation of the European Space Agency's Columbus Laboratory. Astronauts Rex Walheim, Stan Love, and Hans Schlegel also replaced several components of station hardware over the course of 3 spacewalks.
And liftoff of Space Shuttle.
And in May 2009, the STS-125 mission became the first flight in 9 years for Atlantis to a destination other than the International Space Station.
Bypass across the board, Scooter, no action.
STS-125 was the final servicing mission to the Hubble Space Telescope. During the 13-day flight, the crew outfitted Hubble with 2 new imaging devices, the Cosmic Origins spectrograph and the Wide Field Planetary Camera 3. Over 5 complex spacewalks, the crew replaced and upgraded many key components on the venerable telescope, giving Hubble a new lease on life and extending its vision to beyond the limits of our solar system, with a clarity once thought to be inconceivable. Atlantis has traveled more than 115 million miles in the pursuit of exploration. Its legacy enabled NASA and its international partners to accomplish some of the most complex work in human spaceflight history. Work that has yielded immeasurable benefits and allowed us to greatly advance the frontiers of knowledge.
Когда они познали себя, они познали мечту и небо. Небо открыло им землю, изрезанную морщинами рек, выглаженную полями и согретую заботой человеческих рук. Здесь, на земле, созревала их мечта, и небо поднималось все выше. И был уже близок тот день, час и минута, когда их земные ладони коснулись черного неба космоса. Тайное приближалось. Тайное дарило новую тайну. И они шли к этой новой тайне с надеждой на радость победы, печалью утрат и с верой в тепло земных объятий. Когда они познали мечту и небо, они познали космос. И космос открыл им главное — великую жажду Земли. Утро 14 января 1969 года. Пока этого человека знают немногие. Знают те, с кем он вместе шагал по трудной дороге тренировок и учебы, с кем познал тишину сурдокамеры и бешеное вращение центрифуги, прошел испытания жарой и холодом. Через 2 часа, когда лавина огня обрушится на Землю, и белое тело ракеты унесет в океан Вселенной космический корабль «Союз-4», имя этого человека узнает весь мир. Люди прочтут в газетах, услышат по радио: космический корабль услышат по радио: космический корабль пилотирует гражданин Советского Союза, летчик-космонавт, подполковник Шаталов Владимир Александрович. Но это будет только через 2 часа. А пока минуты прощания, последние земные заботы. Совсем рядом мгновение, ради которого так много и долго работали люди.
What about this, what you told me before about the ranging? Do you still have some doubts about that, or is everything resolved now?
We're getting good ranging data now, Yuri.
Сейчас мы получаем хорошие данные по измерению дальности.
9/10 of a mile and have him wired.
Super, Tom.
Houston flight, Zug Москва. Корабль «Союз» готов к стыковке.
Sure, the flight director and the other people here in the control center are happy to know that. I'd like you to know that Apollo is go for dock also.
Спасибо, Юрий Степанович, очень рада это слышать. Я уверен, что все остальные наши управленцы и руководитель полета будут тоже очень рады это слышать. Что касается Аполлона, Аполлон тоже готов к стыковке.
And if you'll excuse me just for a minute, I'll pass that word on now.
Вы меня сейчас извините, я передам ваше разрешение на стыковку.
You can see his antennas from out here, deck gas.
Roger. Apollo Houston, I got two messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
All righty, sounds good. Palovina, Mila, Alexei.
Mid-July 1975. An American Apollo spacecraft and a Soviet Soyuz spacecraft prepare to join in Earth orbit, 140 miles above the Atlantic near Portugal. During their two-day joint flight, astronauts and cosmonauts transferred between spacecraft. They conducted space experiments, and they tested a compatible rendezvous and docking system, evaluating its potential as the universal standard on future spacecraft for docking and rescue. The mission climaxed more than 3 years of planning and preparation, a time during which differences in language, in technology, in political creed were set aside in favor of the common goal. This was the mission that opened the door to international manned spaceflight, the mission that set the course for joint flights of the future. This was the mission of Apollo Soyuz. In the pre-dawn calm of July 15th, the methodical countdown of Apollo moved with customary precision toward a mid-afternoon launch. Of lesser note was the fact that this would be the last flight of Apollo Saturn. And as the countdown narrowed, chances are that more than one member of the launch team reflected on other proud days of Apollo, like its 9 flights to the moon, 6 of which resulted in landing men there. It's 3 flights to Skylab, transporting crews to the orbiting space station. And now, in 9 days, the entire Apollo program would pass into history. Apollo would make way for a 2-way reusable vehicle, the Space Shuttle, scheduled for its orbital flight debut in 1979. But today, it is Apollo Soyuz. And as dawn approaches the Florida coast, a similar drama is nearing climax, half a world away. The scene, Baikonur Launch Complex in Kazakhstan, central USSR. The Soyuz spacecraft, its crew approaching the end of pre-launch checks, is about to signal the start of this historic mission. At Mission Control Moscow, flight controllers monitor Soyuz as it gathers momentum en route to orbital altitude. Less than 9 minutes after launch, Soyuz, powered by triple booster stages, is inserted into its assigned orbit.
This is Apollo Saturn Launch Control. The countdown has proceeded smoothly this morning, and the flight crew here at the Kennedy Space Center were alerted about 10:30. They're right now in the suit room at the Manned Spacecraft Operations Building, donning their spacesuits, and they're scheduled to leave the suit room about 12:37 for the trip out to Pad B. The weatherman continues to be cooperative.
A near-perfect day for the launch. Made to order for the thousands lining the roadsides and beaches to witness this Apollo-Saturn finale.
At 3.1 seconds in the countdown. We'll hold down till thrust builds up.
11.
Engine ready light on. 10, 9, 8, 7, 6, 5, 4, 3, 2. Engine sequence start. 1, 0. Launch commit. We have a liftoff. All engines building up thrust. Moving out. Clear the tower.
Roger, tower clear.
Roger, Tom, you got good thrust on all engines. You're right on the money.
30 seconds, we're on the way.
Stand by for mode 1 Bravo. Mark, 1 Bravo.
1 Bravo, 2 Gs.
Roger. Cabin pressure's coming down. Roger.
Apollo Houston, you're good. Go for station.
Roger, go for station. Okay, and that light is out on the 4B. We got acceleration.
Roger.
Apollo is placed in orbit.
5, 6, go. Now.
And before the flight is 3 hours old, the docking module is smoothly extracted from the second stage booster, left trailing behind. During the next 40 hours, Apollo, through a series of maneuvers, will slowly close the orbital gap with Soyuz. The two crews will meet again, not as members of this or that nationality, but as friends who for 3 years shared their separate cultures and customs, and a part of themselves. Preparing for their mission, Soviet and American crews spent a good deal of time together. In formal mission training, in learning about the other man's culture, in getting to know the man himself.
In the United States, I want to visit Hollywood.
Alexei Leonov, Soyuz commander.
Because I want to be a movie star.
Colonel in the Soviet Air Force.
No, I don't want. Tom Stafford want.
In 1965, on the flight of Voskhod 2, he became the first man to walk in space.
Right now, we're optimistic we'll meet the launch schedule. The hardware's in good shape. As far as astronaut and cosmonaut training, we're in good shape. But when you put the whole thing together,
the Apollo commander, Air Force General Thomas Stafford.
We have a lot of concern about it.
Before this mission, he had flown 3 times in space. He was commander of Apollo 10, the mission that orbited the moon and qualified the lunar module for subsequent lunar landings. A civilian and a veteran of the U.S. space program, Donald K. Deke Slayton. One of the original 7 astronauts, he was scheduled to pilot the 4th manned Mercury flight. A slight heart irregularity interrupted his flight career. He was returned to full flight status in 1972 and assigned to Apollo-Soyuz as docking module pilot. Another civilian crew member, Valery Kubasov, aged 40, the Soyuz flight engineer. On Soyuz 6, he successfully performed the first welding experiments in the zero gravity of space. Rounding out the American crew, Vance Brand, civilian, aeronautical engineer, former test pilot. He's been a backup crewman on previous flights, but this was his first trip into space. He is the command module pilot. As this was a time of mission preparation, it also brought together engineering and technical specialists from both sides. Heading up the teams were Dr. Glyn Lunny, the American project director, and his Soviet counterpart, Professor Konstantin Bushuyev. Under the direction of these two, an atmosphere of cordiality and mutual respect developed that pervaded the many months of meetings and negotiations. Joint groups were assigned to 5 general areas: communications and tracking, life support and crew transfer, mission planning, control and guidance, and mechanical design. This latter category included the building of the first universal docking system. The system's development, its ultimate testing in space, constituted the specific goal of the Soviet-American Space Agreement signed in Moscow in 1972 by the chief executives of both nations. Although each nation designed and built its own half of the docking system, the interface, that is the physical mating of the two, was a single design. Considering the language barrier, the differing technologies, 2 diverse political systems, the development program moved with relative ease. There were differences, to be sure, but none that was above negotiation and compromise. Perhaps Professor Bushuyev put those differences in the proper light. He said, "In our joint work, there has been only one contradiction. Dr. Lunny drinks black coffee, and I drink mine with cream."
Okay, copy.
This is Apollo Control. Apparently the TPI maneuver was indeed successful. Tom Stafford reported from Apollo that he was station keeping with Soyuz. Both control centers, Moscow and Houston, have given a go for docking.
Soyuz Apollo, track switches. I need you 5x5.
Apollo Houston.
Can you see the Soyuz?
He's hidden behind the docking module. Here he comes, just above the docking module. Looks real pretty. Good show. Let's say that. Looking fine.
I'm approaching Soyuz.
Oh, please don't forget about your engine.
Less than 5 meters distance.
3 meters.
3 meters.
3 meters.
1 meter. Contact. Capture. We also have capture.
Roger, Tom. We'll pass it on.
Soyuz and Apollo are shaking hands now.
Houston Apollo.
Go ahead, Tom.
Говорит to Professor Bushuyev. Tell Professor Bushuyev it was a soft docking.
Around the world, millions watch and listen as the 2 spacecraft become one. Now they wait for the next dramatic event, the meeting of Soviet and American crews.
All right, on a show. Открываю Luke 3.
Okay, the camera.
Ha-ha! Здравствуйте! Got it? It'll stay open.
Go ahead. Go ahead, Tom.
Alexei. Mr. Mullen? Okay, turn on the camera. Hit the remote. Okay. Here. Glad to see you. Here.
Alexei. Очень рад видеть вас.
Очень рад. Это роща день. Советский Союз. Соединенных Штатов.
In the first crew transfer, astronauts Stafford and Slayton are hosted in Soyuz by cosmonauts Leonov and Kubasov. Vance Brand remains behind to monitor Apollo systems.
In the name of the Soviet people and from myself personally, I am
To mark the occasion, leaders of both the USSR and the United States relay their congratulations.
Of the Soviet spacecraft. New possibilities are opening up for fruitful development of scientific cooperation between countries and the peoples in the interests of peace and progress of all humanity. I wish you successful completion of the planned program and a safe return to Earth. Leonid Brezhnev.
The astronauts are online, sir.
Gentlemen, let me call to express my very great admiration for your hard work, your total dedication in preparing for this first joint flight.
It's taken us many years to open this door to useful cooperation in space between our two countries. And I'm confident that the day is not far off when space missions made possible
by this first joint effort will be more or less commonplace.
And may I say, in signing off, here's to
a soft landing.
Thank you very much. Thank you, Mr. President.
Among ceremonies scheduled for this first day of joint flight are the exchanges of national flags by the spacecraft commanders. Later, they sign certificates of docking for the Paris-based Fédération Aéronautique Internationale, the organization that validates all aviation and spaceflight records. Finally, they sit down to dinner in space, Russian style.
Right now, I've just finished some strawberries reconstituted. I'm just eating some too. We're getting ready to eat some borscht, as you can see here.
Following breakfast in their separate spacecraft, the crews begin the second day's slate of activities, which includes working on the joint experiments. An electric furnace is aboard for high-temperature testing of metal alloys and crystal material samples. One of these samples is a joint experiment. Investigators believe that uniform mixtures of metals and perfect lattice structures can be consistently achieved in materials in the non-gravity of space. In the day's first transfer, Vance Brand visits Valery Kubasov in Soyuz, and Colonel Leonov is hosted by astronauts Stafford and Slayton in Apollo.
Hello, American people. The first Soviet-American TV.
Activities begin with a tour of both spacecraft. Kubasov shows Soyuz to the American audience. Tom Stafford explains Apollo to Soviet viewers.
It's been a most rewarding 2 days here in space, working with the Apollo-Soyuz project.
Soon after the third transfer, the spacemen field questions from the Soviet and American press.
The Union and the rest of the world has seen is the results of the determination, the cooperation, and the efforts by the governments of the two countries, by the managers, engineers, and all the workers involved. It's been a very rewarding experience.
Roger, it's Moscow's turn to ask the questions that have been proposed by the press there.
Thank you, Bo. Алексей Леонов.
Насколько считаете вы комфортабельным корабль «Аполлон»? И как вам нравится американские
consider the Apollo spacecraft to be, and how do you like the American food?
Я сегодня 6 часов пробыл на космическом корабле «Аполло», это в космосе. Но as all philosophers say, the best part of a good dinner is not what you eat, but with whom you eat. Today,
North of New England, as the workday ends, Tom Stafford presents Alexei Leonov's spruce tree seeds to be planted in Russian soil. A gift from the American people to the people of the Soviet Union to provide a living memorial to the flight. The spacecraft commanders also joined the two halves of an Apollo-Soyuz medal. One half launched with Soyuz and the other half with Apollo to symbolize the link-up in orbit. When time comes to retire to their own craft, it's do svidaniya and goodbye. The joint experiments would resume the following day, but only by voice. The next face-to-face meeting would be in Moscow in September.
This is Apollo Control. At acquisition here, we should have confirmation of undocking and a real-time television picture of Soyuz from Apollo as it backs away in preparation for the solar eclipse experiment.
Solar eclipse occurs briefly and infrequently on Earth, giving scientists too short a time for adequate study. But with two-manned spacecraft and proper maneuvering, a solar eclipse can be simulated. Thus, with Apollo blotting out the solar disk, the Soyuz crew trained their cameras on the solar corona, recording pictures for later study. They dock again, providing yet another test of the compatible docking mechanism.
Apollo Houston, it was a beautiful docking. We had a good picture. We can see Italy coming up in the Mediterranean right now. Apollo Houston through Atchen, we're hearing your calls.
Roger, we've docked. Everything was on time, though.
After some 3 hours, the two spacecraft separate for the last time, and Apollo maneuvers into position for the final joint experiment. Ultraviolet absorption, the measurement of oxygen and nitrogen particles in the upper atmosphere.
181, we would like the 3 TV cameras.
Apollo directs light beams of special wavelengths to a reflector mounted on Soyuz. The beams bounce back to Apollo and are there analyzed by a spectrometer. It is the first such measurement by this method. The results have given investigators a clearer knowledge of outer atmospheric makeup, including the quantities of ozone in the upper atmosphere. Termination of the experiment signals the end of the joint phase of the mission, and the separation between spacecraft grows more distant with each successive orbit. Apollo will fly solo for 4 more days, but the crew of Soyuz makes ready for return to Earth.
Good morning again. Jim Hartz and Alan Shepard from the Mission Control Center in Houston, Texas. Live this morning, the Soviet spacecraft is about to land in the Soviet Union.
The Soyuz recovery, a focal point of media coverage, is typical of worldwide interest in the mission. Not since the first landing on the moon 6 years earlier has the Houston News Center seen this much press activity. Beneath its single striped parachute, Soyuz settles to Earth in Soviet Central Asia. Retro rockets cushion the impact.
Contact. The parachute.
3 memorable years have ended. Alexei Leonov and Valery Kubasov have secured yet another place in the history of spaceflight. Apollo continues in orbit, carrying out the remainder of the 27 experiments in space sciences, life sciences, and applications. Among the less notable passengers aboard are numbers of killifish. Sealed in seawater, they are in key stages of maturity. Scientists want to pursue an earlier investigation in which fish taken into orbit on Skylab had orientation difficulties in zero gravity, while those that were hatched in orbit adapted quite well. On return to Earth, the specimens will be compared to similar stages of Earth-raised fish. Through highly refined instruments, they look out in our galaxy and beyond. A new source of radiation is found, the extreme ultraviolet, which many scientists thought would remain forever invisible. Others felt it didn't exist at all. The discovery ranks high in importance and may open a new branch of astronomy for studying the universe. They attempt to locate the sources of soft X-rays. They probe the temperature and abundance of the interstellar medium. They test ways of long-term monitoring of aerosol particles in the atmosphere, which may have profound effects on our weather and environment. They look back on Earth on those features that will yield the greatest results: geological features, the oceans, the deserts, pollution patterns, weather formations, all the phenomena that comes under the general heading of Earth resources. As the mission comes down to the wire, the docking module is jettisoned, and it too becomes part of an experiment. With the two instrumented spacecraft close together in the same orbit, it is possible to measure their relative movements caused by variations in Earth's gravity. The technique provides a means of accurately mapping the Earth's mass structure on a global basis.
Final.
Go.
Guido.
Go.
Retro.
Go, flight.
GNC.
Go, flight.
Apollo Control, 99 hours, 29 minutes, phase elapsed time. Flight Director Frank Littleton.
Go.
Pulsing his flight controllers. ECOM reports everything looks fine.
Go for the burn.
Okay, Crip, everything's up in great shape up here. The only thing we're concerned about is that you've got all your splashdown parties coordinated, over.
Well, I've been working on that.
Okay, sounds good.
In Pacific waters west of Hawaii, Apollo reaches the end of its journey and the end of an era.
Waving to the crowd, assembled here on the hangar deck of the USS New Orleans. Scott Logan giving them a few more words of briefing about the ceremony, which will take place in just a few moments. Now they walk down a red carpet course. Thank you. I know it's customary to say that it's great to be back. We're happy to be here.
We didn't know it at the time, but during re-entry, gas from the attitude thrusters had entered the command module, creating a hazard. Quick action by the crew in recognizing and correcting the problem avoided a potentially tragic incident. They were later hospitalized in Hawaii for observation and treatment. The symptom cleared in a few days, and the crew was released. The spirit and the letter of the 1972 joint agreement had been dramatically fulfilled. Hopefully it represents a prelude to the future, to a time when all mankind will share the work and the dividends of space. The Space Shuttle is a major step in that direction. The shuttle will transport into orbit a European development called Space Lab. With 10 countries of Europe sharing construction and cost, men and women of many nationalities will be able to apply their creative talents aboard Space Lab for the benefit of the world community. But for Space Lab, for Shuttle, for all the cooperative space efforts to come, groundwork has been laid by Apollo-Soyuz, the model for the future.
a recent 12-month period, over 1,000 research sounding rockets were launched, principally from the North American continent. With so many satellites in orbit, why does the United States launch so many sounding rockets? For one thing, the relatively low cost. For another, the ability to carry relatively large payloads. The ease and low cost of payload recovery. The checkout of experiments which may be later flown in satellites. In this chart of the atmosphere cross-section, you can see the gap between balloons and satellites. Sounding rockets fill this gap, contributing to the world's scientific knowledge about weather and the ionosphere. At NASA Wallops Station on the Atlantic Ocean in Virginia, we can examine some of the facilities to guide the establishment of a new rocket research range. Procedures shown in this film have been modified from U.S. operations to fit the capabilities of a newly established range. What are the requirements of such a site? Obviously, the more room available, the better. And any plan should provide for expansion if possible. A research range tends to be shaped as a sector, as wide as practical. The size and angle depend greatly on the population density and safety considerations. Locating a firing point on a shoreline usually makes the impact area easier to clear. However, with land ranges, recovery of payloads is easier. Recovery of experiments brings back sample data, such as particles, camera film, or emulsion packages, and may permit reuse of the scientific instruments. The search for a launch site should take you as far from populated areas as possible and still get access roads, communications, water, and electrical power. Consider the number of people, perhaps 25, who will require living space, and the conditions of their habitations, temporary or permanent. Having selected the site, let us look at the requirements of a launch facility, considering that each nation has its own special problems, experiments, and boosters, which may require modifications in this hypothetical plan. Let's look first at the rocket storage areas, located at least a half kilometer from any area where people will normally live or work. Ready storage may take this form, in a remote building, farther too if there's no barricade. Control the access of people to this area and avoid the possibility of fire. Each rocket is electrically grounded, and the building itself is grounded to a well-buried girdle of copper wire or strip. Sometimes boosters are stored in open sheds, awaiting preparation for use. A separate building is usually needed for handling the payload, especially if pyrotechnics or explosive grenades are to be handled. Depending on the payload requirements, this area is at least 10 meters square and located with access to the rocket assembly building. Here we see electrical checkout equipment and handling systems provided depending on the nature of the payload. For example, for the grenade experiment, the timer is checked with a system of telltale lights. This test answers the question, does the timer deliver firing pulses at the proper instant and in the planned sequence? Provision is made for tools required in rocket and payload assembly, and sufficient spare parts as required. If the checkout shows a weak component, it must be replaced, or the repairs may delay the firing. Many launch facilities include buildings which contain the telemetry equipment, tracking equipment, and data recording. Some Sometimes these are in vans, or sometimes in the blockhouse. Telemetry is monitored during calibration and checkout. Telemetry during the flight is received, recorded, and displayed. Workspace and test facilities should be provided to perform multiple TV. Sometimes boosters are stored in open sheds, awaiting preparation for use. A separate building is usually needed for handling the payload, especially if pyrotechnics or explosive grenades are to be handled. Depending on the payload requirements, this area is at least 10 meters square and located with access to the rocket assembly building. Here we see electrical checkout equipment and handling systems provided depending on the nature of the payload. For example, for the grenade experiment, the timer is checked with a system of telltale lights. This test answers the question, does the timer deliver firing pulses at the proper instant and in the planned sequence? Provision is made for tools required in rocket and payload assembly, and sufficient spare parts as required. If the checkout shows a weak component, it must be replaced, or the repairs may delay the firing. Many launch facilities include buildings which contain the telemetry equipment, tracking equipment, and data recording. Sometimes these are in vans, or sometimes in the blockhouse. Telemetry is monitored during calibration and checkout. Telemetry during the flight is received, recorded, and displayed. Workspace and test facilities should be provided to perform pre-flight assembly and electrical checkout of instruments. Tracking equipments may be remotely located, such as this GMD-1 tracker, or a radar such as SCR-584. Indications from such equipment are relayed to the instrumentation facility. Sometimes van mounting of instrumentation gives flexibility in experimenting and permits the return of expensive equipment to the base laboratory for calibration and testing during inactive periods of the range. Ground support items are as important as the rockets and their payloads. Weather data correlates ground observations with sounding rocket observation and also determines the ability to launch. Wind data and wind shear information are particularly important in the launching of simple research rockets, which in some cases are quite sensitive to winds. Locate the launch pad a safe distance from any other facility, depending on the rockets, with a clear flight path to the range area. The launch pad is at least 15 meters square. It is provided with floodlights, loudspeakers, and telephone. Sometimes pad cameras observe the launch and document the activities. Other cameras on remote sites may observe test phenomena. The launchers are usually simple rail types, selected to match the type of rocket. Elevation and azimuth are adjustable, as changes in wind conditions often require changes in settings, even as the firing time approaches. The control center is located so that underground power and communications cables can be run to the launch pad. Sometimes referred to as the blockhouse, this may also contain the instrumentation. Obviously, this building has the heaviest roof and wall construction of concrete or cinder blocks. Windows, if provided, must be thick, 10 centimeters or more. Instead of windows, some facilities use closed-circuit television equipment to permit close observation with personnel safety. Provided technicians are available for maintenance, cost of this equipment is relatively low. Multiple TV cameras provide varying viewpoints, usually with pictures clearer than shown in this motion picture film. Simple radar is used to track the payload. Sometimes these radars also observe the area for range safety. Radar data is photo-recorded for analysis of trajectory. Precision oscillators provide time code generation, feeding a series of accurate pulses to recorders, cameras, and other instrumentation. Often, remote sites are used for cameras or tracking. These require timing signals and communication by landlines or radio. Storage, assembly, communications, control, timing, telemetry. These are the major elements of a launch facility. Starting at T-2 days, we're going to see how these facilities are used to launch one type of payload, in this case, a grenade experiment. The assembly and the initial checks on the payload may take up to 1.5 days. We want to be ready to fire at the selected time. At about T-12 hours, we move the rocket from the storage area to the launcher. Rockets such as this need the proper dollies and handling equipment for convenience and safety. Notice, too, the roadways provided. Handling equipment is available to position the Nike for smooth movement onto the launch rail. At about this time in a remote area, the grenades are being loaded into the plastic nose cone. At altitude, these will be exploded in series to provide successive measurements of the speed of sound and derivation of temperatures. The payload, minus grenades, but mated with the second stage, is fastened to the booster on the launch rail. This should be completed by T-4 hours. About this time, we begin observing the winds and other meteorological parameters to make our first impact prediction. From weather data, we can determine preliminary launcher settings for impact in the desired area. After the nose cone is installed with live grenades, we want the minimum handling of the rocket by the least number of people. Now we begin to keep close track of the time beginning an actual countdown. Range safety information may come from range surveillance aircraft or from surveillance or tracking radar to assure that the range area is clear. In the instrumentation area for this grenade experiment, final equipment checks are made on the sound ranging recorders. The recorders will obtain data from a quiet area nearby, where a series of sound ranging microphones are installed under these covers. A final check of the weather for the wind weighting, a process of assembling data and computing impact areas. Adjustments can be made to the launcher for safe impact, considering the current winds.
All personnel will take cover and remain under cover until T+2 minutes.
In the instrumentation section, all settings are checked. Telemetry and recorder settings. In the control center, range safety is again verified, and timing and instruments are checked following a countdown manual. The project scientist verifies that the experiment is ready and switches instrumentation to internal power in the rocket. Transponder to internal power. Recorders are turned on for tracking and telemetry. Sound ranging recorders on.
20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, mark.
From this tracking recorder, we get information as to the range and direction of the payload at the time of each grenade explosion. We are about to see the time of arrival of the sound waves at each of the sound ranging microphones. When this data has been reduced and analyzed, it will tell us the temperatures and winds to altitudes of almost 100 kilometers. For different rockets, for different experiments, for different nations, procedures may vary, facilities may vary. Rocket ranges need not be complex. Recently, one nation set up a range for $250,000. Depending on the experiments, low-cost rockets may be fired from simple ranges so that many countries can do substantial research for the advancement of scientific knowledge in all nations.
A new door to space opens. The space shuttle. Everything that has gone before in space, this magnificent treasure, is prologue. We are beginning a new and exciting age, signaled by the flight of Columbia into Earth's orbit. Columbia is the first of a fleet of ships of the Space Transportation System.
Houston, Columbia, Hattie Reed.
The others to follow,
Roger, reading you loud and clear now.
names which evoke the spirit of our purpose on this new ocean. Challenger, Discovery, Atlantis.
And the monitors are all set up.
The working environment aboard will be quite ordinary. Yet the meaning of all this to us is far from ordinary.
Okay, Joe, I think I'm about done here. I'm going to head on downstairs and fix us something to eat.
Space Shuttle, taking as many as 4 satellites into orbit, has the capability of retrieving orbiting satellites, repairing them in space, or bringing them back to Earth.
Okay, Houston, Columbia, we had a good IMU alignment. Time was 4:55:57, and numbers are on the tape, and we did get the verification.
Roger, we copy.
Okay, Fred, 205.
Roger, we copy.
Okay, Fred, 205 and 20,100. 20,230.
Historian James A. Michener, in an address to Congress, said, "There are moments in history when challenges occur of such a compelling nature that to miss them is to miss the whole meaning of an epoch. Space is such a challenge.
I'm James Michener. For most of my working years on this planet, I've been chronicling the rise and fall of human systems. If there is one thing I'm convinced of from years of studying history, it's that enemies do not destroy nations. Time and the loss of will brings them down. To see that this does not happen to this nation of ours, the United States cannot retreat from the challenge of our age. Each era of human history progresses to a point at which it is eligible to wrestle with the great problem of that period. For the ancient Greeks, it was the organization of society. For the medievalists, the spelling out of their relationship to God. For the men of the 15th and 16th centuries, the mastery of the oceans. And for us, it is the determination of how mankind can live in harmony on the finite globe we call Earth, while establishing relationships to an infinite space.
Okay, got EVVA on. We're ready for final suit pressure adjustment.
I am struck with wonder at the energy being expended by thousands of people, not only in the United States, but around the world, who have worked long and hard to overcome technical setbacks to make space travel available, not only to astronauts, but to anyone who wants to journey above our planet and work in space. The space transportation system they've developed introduces the decade of the 80s to the spaceship Columbia, the first of many spacecraft that will be propelled not on the top of expensive one-time boosters, but by a space transportation system that can be used economically over and over again.
Our endeavor, guided and informed by a history of successes in spaceflight, is of immense proportions. 10,000 NASA employees at 6 research centers across our nation and other centers in Canada and Europe. The effort has been advanced